we have had quite a close relationship in the lab, right? So we wander around and we see every single one of you. I know what you've been up to. Now that can work in your favour. So if you show me which is your circuit, and yeah, that helps me enormously when I do the marking as well. Yeah? Does that make some kind of sense? Explanation of operation. Even if you don't understand, and we did say this right at the beginning, didn't we? We said, you don't necessarily have to understand how the circuit works. But you're in the lab and we do, so glean it out of us. Is the message there, I think. The information is out there. That circuit, if you search for it, is out there, and there's a reasonable explanation of how that works as well. So there's no excuse for, I didn't know how it works. Because it doesn't matter, even if you don't, there should still be some kind of explanation there. So 10% for that. Evidence of measurements. So I don't mean on the real board, although if you have any of those, you could include those, I guess. I mean in multi-sim. So what's the voltage? Shh. In multi-sim, you can measure the DC levels, you can probe, and you can see the AC signals. You can see what happens after the rectification. You can see what happens when you turn the transistor on and off. To make the buzzer work, all that kind of stuff. So measurements. Now don't do what I have seen in the past with several people, is they just attach a probe to every single point in the circuit and then expect to get full marks for the measurement. Well, you're not going to, because you're not doing a meaningful measurement. Why would you measure 0 volts? I mean, it's just silly, right? Why would you measure VCC? Just silly, right? So it's got to be sensible measurements. Justification of choice of circuit, on that little bit there, you could compare this circuit to other metal detectors. And my takeaway from that would be that we're using this one because it's blindingly simple, right? It doesn't have integrated circuits in there. It's fit for purpose, but it doesn't have very much sensitivity. So that's when you start to talk about justification. So the lecturer, me, has chosen to use something really simple so you can explain it, but it means that it isn't actually a very good metal detector, let's be honest about it. Yeah, so it's that kind of discussion I'd expect to be in there. Critical reflection on achievement. That's where you get some humility in this. So most of it went according to plan, however, I found it really difficult to be able to understand the section about creating the oscillator or the feedback from the two coils or the way in which that worked. That was difficult for me to understand. That's the critical reflection. That's where you take your own work apart. Now anyone can write, I did the best job in the world, but that won't get you those marks. But if you tell me from this, I learned that having the track size too small is very detrimental when it comes to having the PCB made. And I also learned that it's critical of the number of turns, that kind of language. I also learned that I need to be very careful when I insert the diodes into the board, because there's two different styles of diodes there. Simulation in multi-sim. As best you can, break that circuit into the 3 chunks, I suggest, and evidence of operation. Now, if that evidence of operation is just a mobile phone shot of you with a piece of metal next to it, that's fine. That's fine. But the evidence of operation, I think, is going to be more meaningful if you can show me the parts of it working inside multi-sim. Obviously, a screen grab of your printed circuit board goes without saying. That's the deliverable. So if I'm your boss, I've asked you to make a printed circuit board of a metal detector. So that's going to feature very highly on that. So you might want 2 or 3 shots of that. Okay, also embedded in there is what we call a bill of materials. Now, Mike's just going to design something for you in Ultiboard, and he's going to have a chat with you very shortly about the 2 stages which are missing in this. Okay? So one of the first things that you need to be able to do is you need to be able to cost this. So how much does it cost to make? That's not an easy question to answer because I can buy one transistor off eBay for about 50 pence, or I can buy 100 transistors for, you know, £2.50 or something like that if I start ordering in bulk. When you produce your bill of materials, state what you've done. So if you think you're going to make hundreds of these, then bulk order and then work it out as per unit. So, you know, you might decide that you're going to make 100 of these, so you're going to buy 100 of every single component. That's going to get your cost down, or your per unit cost, but you're still going to have the initial cost where you have to buy them all. That's your decision on that. I personally would order a minimum of 100 of anything and then scale it by 100, and that I would use in my final costing, but that's entirely up to you. So a bill of materials. Now this becomes more important in the second assignment, and we'll give you a proper form to do this on, but at the moment you're just going to do that inside your report. Okay? What's the missing thing, the last step? Anyone help me on that? Well, we designed a PCB, we've simulated a PCB. What haven't we done? I love definitely science. So we've designed it, we've simulated it. What haven't we done?
That's it. It just lives in the cloud forevermore.
Well, that's it. It's just, we haven't built it, right? So how do you build it? I want that PCB, like the young lady's got there. I want to hold it in my hand. I want to take it off to the soldering room and solder components in it. You've got to make it, right? So how do you make it? Well, you take it, or you have to export the Gerber files, and those Gerber files then have to go into a website. Now there's lots of manufacturers in the world that will make you PCBs at very, very reasonable cost. And when you put this in, which you're going to do later on today, because Mike's going to show you that in about half an hour or so, you'll probably be astonished at how cheap they are. Compared to if we made it, it would cost us more to make it than it would to have it manufactured. So you export the Gerber files. We're going to use a company called PCBWay. You put your details into PCBWay and you do a sanity check on it. So you're going to make sure that all the information that you've given to the company makes sense. And then you're going to go through the motions, but you're not actually going to pay and get it delivered. Okay? There's no point for this assignment. But what I want to see is I want evidence that you've uploaded those files to PCBWay, that PCBWay have acknowledged that they've got your PCB, and this is what it would look like, but you just haven't pressed the buy it now button. There's no commitment, they're not going to send you adverts or anything like that. You just haven't gone to that final stage, which is the please make me 100 boards or something like that, okay? Yeah? So the two things you haven't done yet, bill of materials and uploading to PCBWay ready to have that final board made. Okay? And we'll do that very shortly.